Very good. Then minus equals. Simplify 4 by 4. That's why I put it in. We never multiply before we simplify. That's why I wrote it as 4 over 1. So you can simplify. So the answer is very good. So we move 4 to the other side. Negative 3x equals negative 1. Therefore, x equals how much? Awesome. Any questions? Is this okay, everyone? Any questions? I don't want to lose anyone. Is it okay? So where was the problem? You mean here? I divided both sides by 4. 4 divided by 4 is 1. 3 divided by 4 is 3/4. So this is, we divide by 4. I have to clean it up. And then I change this into these two. I cannot solve this. I don't know how. If I can't replace this by these two, I won't be able to solve. So don't cross it out like that. I'm just making a point. And then we solved the two linear equations. Not yet, just the first one. So now I have 1 minus 3/4 x equals negative 3/4. Do we continue multiplying both sides by 4? Okay, so let's multiply by 4. However, it's easier and better to write it as 4 for the first term, but as 4 over 1 for the second one, and as 4 over 1 for the last one. Why? Because then you see that you simplify and you see that you simplify. So we have 4 minus 3x equals, and the other side is negative now, negative 3. And I move 4. Negative 3x equals negative 7, and the other possible solution is, careful, I have to divide by negative 3, and I have negative 7, so the answer is 7. Very good. That's how we solve absolute value equations. And I want to, 101 is recommended, so I'm going to work on 102. Any questions? So this is basically number 6. Equations that are models, and we solve for a letter. Equations with different variables in it, with several variables. And we are specified which one to solve for. So 102 on page 186 is r equals the square root of a over 4 pi. We are told solve for a. Bless you. So we are told to solve for a. What type of equation is it? A little r, yes. Sorry about that. So what type of equation is it? I have to look at the variable when I decide what it is. So what type of equation is this? Is it absolute value? No. Is it linear? No. Is it rational? Say it again. Of course. I was going to eventually get to that. Of course. How do I solve a radical, which is a square root in this case? Both sides. Very good. So the left-hand side is r squared, and the right-hand side is? No cell phones, please, Tiara. Please put it away. Please, I know it's very important, but not now. a over 4 pi. So what is the final step? That's it. 4 pi times r squared. Very good. Any questions for me? The last section of chapter 1 deals with linear inequalities and absolute value inequalities. Yes, please. Any questions? So 1.7, linear and absolute value inequalities. So let's look at a linear inequality first. Yes, why not? Let's choose one with fractions. Just because I want you to never be afraid of fractions. 3x divided by 10 plus 1 greater than or equal to 1/5 minus x over 10. Is this a linear inequality or a rational inequality? It's not rational because it doesn't have x in the denominator. So if there is no x in the denominator, this is still linear. Good. And those fractions bother me. So what do I multiply both sides by? And what would be the least common denominator? 5 is not the least common denominator. 10. So we multiply everything by 10. And when I see a fraction, I write it as 10 over 1. When I see just a term, I will write multiply by 10. So 10 over 1 and 10 over 1. What is left from the first term after we multiply by 10 over 1? How much? That's it, because I simplify. Always get into the habit of simplifying before you multiply. Then indeed plus 10, greater than or equal to?
2.
Indeed, because I simplify, I get 2 and I get 1. And minus?
S.
So this shows that we should not be afraid of fractions. And when fractions are involved, we can always get rid of them. Okay, perfect. So now both sides are completely simplified. I will move x to this side and we'll move 10 to this side. When I move negative x to the other side, it becomes? It becomes positive. So 3x plus x is 4x. When I move 10 to the other side, it becomes negative. So negative 10 plus 2 will be negative 8. And finally, I simplify, dividing both sides by? Yes, please.
Is this one of the equations? I know like there's 2 negatives that you're moving, but if there was only 1 negative that you're moving, would the sign flip?
Only when I multiply or divide.
Okay.
Very good question. I'm going to illustrate in a minute.
Okay.
So we divide both sides by 4, so x is greater than or equal to negative 2. Now in interval notation, how do I present this in an interval notation? So here's a real line. So let's take a look. Here's 0, negative infinity, infinity. No units are required here. I just illustrate to see which side we are going into. Bless you. So here's negative 2. Which direction will I find the answers? To the left or to the right of negative 2? To the right, indeed. The equal symbol signifies a bracket. So this is the interval notation, and we like to write x in the interval, bracket negative 2 to infinity, exactly what you see. Any questions on how to write the interval notation? Any questions? Is this okay? Are you with me, everyone, please? Yes? Okay, so the last thing is absolute value inequalities. Yes? So the absolute value inequalities are of two types. So this is the simplest that we looked at a few minutes ago, but in an equation form, and the absolute value of x greater than or equal to 3. So these are two possibilities. When we solve the equation with absolute value, what did we say? That there are two numbers whose distance from 0 is 3. What are those numbers again?
3,
Negative 3 here and positive 3 here. We agree? Good. Again, I need to understand what this is asking me. Okay, I'm really asked to find numbers whose distance from 0 is 3 units or less. Where will I find those numbers? I know I find negative 3 and 3 exactly at 3 units away from 0. But where would I find the numbers 3 units away from 0 or less?
between.
That's the answer, between. Remember again, I'm just making a point, don't erase it like that. I cannot solve this. But I know that now, as you just said to me, Harry, I think, said it, it's negative 3 less than or equal to x less than or equal to 3. He said in between. That was the answer. In between negative 3 and 3, I will find numbers with distance from 0 less than 3 units. So in interval notation, how do I write this in interval notation?
Bracket. And bracket on the other end.
That's it.
3, 3.
Now let's discuss this one. I'm asked to find numbers whose distance from 0 is 3 units or greater than or more. Very good. This is already taken. I can find numbers here whose distance from 0 is more than 3. No. Where will I find them? Exactly, that's the correct answer. The outside. So on the real line, negative infinity, infinity, 0, negative 3, and 3, this portion is already taken by this inequality. Where will I find again those numbers with distance from 0 more than 3 units? Is the outside. Is this and this. So as you see, you probably noticed that this is a more difficult situation than this one. Why? Here I can solve it in a chain. It's very nice. There is no headache here. Well, this one cannot be solved as a chain like it was here. So I have two totally separately different inequalities. One that will show this and the other one that will show this. So can you please tell me how to show this? We have to solve the inequalities first. We are not the solution yet. X. Awesome. This is exactly that. Now, can anyone show this with an inequality? No. If you say 3, then you include this portion. Wow, excellent. Indeed. So it has to be either to the left of negative 3 or to the right of 3. And that keyword or means the union. So this is not that it's just much easier because it's a chain and it has no union. But this one is more difficult to solve and it also has the union in the solution. That's the only way. So then the solution for the second one will be x in the interval negative infinity to negative 3, this interval, union this interval, 3, yes, 3 comma infinity. So let's illustrate with examples. Okay, let's look at 66 on page 203. 66. Through the absolute value of 3, quantity x minus 1 plus 2 less than or equal to 20. Which type is it? Is it the first type, the nice one, in a chain, or is it the other one that requires more work? Okay, I don't know. I'm asked to find numbers whose distance from 0 is
Less
Less
than
than
or
or equal to
20 or
negative.
less than or equal to 20, right? So which one is it? Is it the first type with a chain? Is it the one in between? Or is it the one outside?
In between.
It's the one in between. Good. So then what will you tell me to write?
So it would be negative 20 is less than or equal to x.
In this case, I have all this expression. Very good.
And that would be less than or equal to 20.
That's it. Straightforward. Only because of the less than or equal to, the absolute value less than or equal to. Perfect. So how do I proceed?
You start by taking the 2 out.
Okay,
2
very
on
good.
both sides.
So minus 2, minus 2, minus 2. So negative 22 less than or equal to
3, open parentheses, x minus 1, greater less than or equal to 8.
perfect. Now you have two options. You either distribute or you divide. It's up to you. Distribute, that's fine. So negative 22 less than or equal to,
3x minus 1.
very good, less than or equal to 18. Normally, if you decide to do that, I would have distributed first and then combine like terms, but it's not a mistake. It's fine. We're going to get the same answer. So now, again, I have to get rid of the weakest link. Which one is the weakest link now?
Negative 3.
Yes. How do I get rid of it?
Add 3.
I add 3 to all three sides. So the left-hand side is negative 19. The middle part is 3x. The right-hand side is 21. Final step.
Divide by 3.
Divide everything, all three sides, by 3. So negative 19 thirds less than or equal to x less than or equal to 7. How do I write this in interval notation?
Negative 13, or negative 19 over 3 in brackets. Then 7.
That's it. It's right there, right? Yes,
I
Jesse?
have a question.
Yes.
The greater than and less than sign, if there's a line under it, isn't it always in the interval notation a bracket?
No, if I don't have the equal symbol here and I don't have the equal symbol here, it will be a parenthesis.
Okay.
Yes. The bracket says it includes the end points. The parenthesis says, for example, if I had a parenthesis here, the last number, which is, I don't really know what it is, the last number would have been 6.99999999999, not 7, if I had a parenthesis here. Very good. So let's look at 76. We illustrate absolute value inequality, 76. So the absolute value of 3x minus 3 over 9 is greater than or equal to 1. Is it cleaned up? Yes. It's completely cleaned up. I can't touch the absolute value. It's untouchable. So now all I have to do is think. I'm asked to find numbers whose distance from 0 is 1 or, say it again. Okay, one more time. I'm asked to find numbers whose distance from 0 is 1 or greater than 1. That's the key. That's the key word. 1 or more. Because if I say 20 or less, I'm here. If I say 1 or more, where am I?
Outside.
Outside. That's the key. That's how you differentiate between the two. Good. So this is not a nice one with a chain. It's the other one. So what are the two options then?
Or no, greater than, more, less than 1.
I cannot have greater than or less than.
Greater than or equal to.
Awesome.
And then same thing, just minus 1.
Indeed, but on the other side. Not greater than or equal to -1, but less than or equal to -1. The complete outside. Okay, perfect. Now I know how to solve the first one. What do? I will have to clear the fractions quickly.
Multiply by 9.
That's it. So I have 3x minus 3 greater than or equal to 9. And then I have 3x greater than or equal to, yes, the second one if you want, that's fine, less than or equal to -9. But I was still working on, that's fine, that's fine. We can write both at the same time. So this is 3x greater than or equal to, yes, which means x greater than or equal to 4. That's it. Now the other one, 3x minus 3 less than or equal to -9. This means 3x less than or equal to, I have a -9 and I'm bringing, yes, and I'm bringing a positive 3. Very good. And from here, it cannot be greater than -2. So if both of them are greater than or both of them less than, something is wrong. So now I need a solution with the union in between.
Open parentheses, -2,
Awesome.
bracket,
Yes.
and then it would be 4.
Yes. This one is this, and this one is this. Any questions? So what I'm expecting of you for Thursday is to finish up everything here. If you find 10 problems the same, do just 5. But if you don't do these problems as many as you can, you will not be prepared for chapter 1. Okay? So all these problems should be done as soon as possible. Now, if you have not done anything, just pick and choose 5 problems, 5 problems, 5 problems, 7 problems, and so on and so forth between now and Thursday so you can ask questions. Because I'm trying to finish up this as soon as possible so you can we can have test 1. Okay? So, and at the end, it's on the syllabus. So at the end, I don't remember exactly. So at the end, before we review for the final for test 1, once you have done this sequentially, and after you finish 1.1, do the homework and quiz, whatever, and 1.2, do the homework and quiz, but you have to study. And remember, there are tons of problems, of examples. Solving a linear inequality. Solving a linear inequality containing fractions. This is only from this section. Solving linear inequalities again. Solving a compound inequality was we just did because we had the absolute value inequality. And then example 9, solving an absolute value inequality. Tells you step by step. So this is what I would do. I would redo the problems done in class, and then I would look at the examples in the book. If you find a method that you prefer here, use it. I'm fine. Any questions for me? Yes, please. Damon, go ahead.
So, doing these is not the same as doing it in my lab.
If you try my math lab without preparing yourself with these and checking the answers in the back and redoing the problems we do in class, I'm assuming, I could be wrong, that a student who does not prepare, it will stumble from the first problem in my math lab. But again, this is an assumption. So I would prepare myself redoing each and every problem that was solved in class till I understand it. I would prepare myself with the examples in each section that was covered in class. Don't forget your thought, just 1 second. And then I will do these problems, check the answer in the back, and then I'll say, I'm solid now. Homework should take very little time. Because if you start punching on the bottom saying, show me an example, and you just mimic, you will not remember the steps. If you just click on show me another example and you just say, oh, okay, they did this here, I'm going to do it here. You're not going to have that available on the test. So I really wanted to remove that possibility. But since the particular course in my math lab was created by my department, I said to myself, well,
I mean that's how I learned because it's slower.
it's not going to work in the long run. I don't think. I apologize if it
I use the book too. You know what I'm saying?
Okay. Well,
That, I mean, but that's,
if it works for you and you write down the steps and you review the steps, maybe. I want everyone to acquire the knowledge and move on. Okay, so I have a little work for you. Any questions for me? Yes, please. Oh, I'm sorry. Yes, I'm sorry. Yes.
So for when we do my math for the quizzes, you get one shot, right?